So the guys at work were talking about doing an upcoming fox hunt, searching for 2-meter transmitters around the general Portland area. And so I decided to just see how expensive it would be to throw together a 2-channel direction finding kit using my Pico 2 from Raspberry Pi. And the answer was $4.51. So I thought maybe I'd give it a try. Now, I added quite a bit to that original bill of materials, but tried to keep the cost as low as I possibly could. I thought I'd walk you through the schematics here. Uh, SMA input, that's about $2.50 for the connector. Limiter slash ESD protection, followed by a bandpass filter. Now, I made the bandpass filter out of just two parts, a 33 nanohenry inductor and a 33 picofarad capacitor. The reason is that way it's only two reels on the pick and place machine instead of what could ultimately be like 5 or 6. And I have the performance here. It's not a great filter, but you're at least going to cut out some of the FM radio stations and going to cut out, a lot of the TV bands and UHF bands. So, it's going to do its job. Next up is the mixer stage. This is about a 50-cent crossover ring diode, which is just fantastic for passive mixing. It's a fairly low power device, so you don't have to hit it too hard. I'm driving it directly from the Pico 2 using, this will be roughly 150 megahertz clock. After the mixer, there's of course going to be a low pass filter to the next stage, which is just a little amplifier, and it's a differential output here because the next mixer, really wants a differential input. Made it out of just 2 resistor packs, a few caps, and 2 of my favorite transistors. 2222's been around forever. And you hear about all these microchips with 100 billion transistors, but sometimes it's easy to forget how powerful even just one is. Looking at the circuits there, this is fairly basic circuit. I'm using some base to collector resistance to push down the overall gain. It also helps stabilize the circuit. In LT-Spice, you can look at the waveforms with an input. You can look at your gain. You can even look at your noise in the circuit. This is especially good if you're just doing a transistor circuit, because sometimes it can be easy to have something where maybe there's a little more noise than you like. The one thing that's nice about this base to collector resistor is you're not only decreasing the gain of the circuit, but you're also decreasing the impedance of the input because of just like in an op-amp circuit, this negative feedback is going to lower the impedance of the input. So this is a great way to match 50 ohms in a transistor circuit, and maybe it adds a tiny bit of noise, but it's really worth it just for that impedance matching. Back to the schematic. Okay, so now we've amplified it. This is just an emitter follower, but I also stuck a resistor on the collector, so it would give me a differential output. Obviously, the collector and emitter are sitting at different DC voltages, so you have some nice big bypass caps here. And here, this TS5A23157 is a really neat part. Let me pull up the data sheet here. What I like about it is how fast it turns on and turns off, because basically when you're thinking about mixers, they're really just a switch, but you're able to turn them on and off really fast with actual RF signals. But if you don't need to turn them on and off quite that fast, something like this, I think it's a 30-cent dual port switch. Now you're in maybe the 5 to 10 nanosecond switch time, but you know, that's still plenty fast for mixing down your IF to you know, to maybe audio frequencies. So once we've mixed down to, I think I'll use probably a 48 kilohertz second IF here. This is just going to be low passed, and then another gain stage, and the input impedance of the actual ADCs on the Pico 2 is pretty high. They're quite noisy. I think the noise figure on these ADCs is something like 60 dB. So you really have to think about that in your design and make sure that you have adequate gain. But yeah, basically digitize and then just send it over to the PC using the Pico 2's USB port. And you've got two channels, phase coherent, at 2 meters with plenty of bandwidth for doing FM demod and angle of arrival direction finding. I know some of you were hoping for another video on my HF work. That is paused while I finish up reworking a prototype board, so hopefully I will get back to you soon on that. But in the meantime, this should be a pretty quick and easy project, and hopefully I can actually get it off the ground pretty fast. Like and subscribe, and I'll try to make more videos soon.